Hi, let us discuss about integral transforms. Integral transform. In mathematical physics, we frequently encounter pairs of functions related by the expressions of form g of alpha is equal to integral from a to b f of t k of alpha t dt. Here, the function g of alpha is said to be the integral transform of function f of t by the kernel k alpha t. So the function g of alpha is the integral transform of f of t by kernel k alpha t. This operation can be said to be mapping of a function f of t in t space into another function g of alpha in alpha space. So we have two functional spaces. One is in t space and other is alpha space. In t space, the functional form is f of t, and in alpha space, the function is represented by g of alpha. Now from t space to g of alpha, the transformation is this equation. G of alpha is equal to integral from a to b f of t k of alpha t dt. Now this t space and alpha space can be represented by time space and frequency space, or position and the momentum space, etc. Time space, frequency space. Okay. And this interpretation, T space and alpha space, takes the physical significance in time frequency relation in the case of Fourier transform, or this is the position momentum space in quantum mechanics. Okay. So now let us discuss about Fourier transform. The Fourier transform of a function is defined by g of omega is equal to 1 by root 2 pi minus infinity to infinity f of t e raised to I omega t dt. So in the case, this is the Fourier transform. And in the case of Fourier transform, our k alpha t, or the kernel, is actually e raised to I omega t. So this is the kernel k alpha t, and instead of k alpha t, here our kernel is e raised to I omega t. Now if you consider the Fourier sine transform, then the Fourier sine transform is represented by gs of omega. That will be equal to root 2 by pi integral from 0 to infinity f of t sine omega t dt. So what is the kernel now? Now the kernel is sine omega t. Now if the kernel is cos omega t, then our Fourier transform will be Fourier cosine transform. So next, Fourier cosine transform, and that is gc omega. Gc omega is equal to integral root 2 by pi integral from 0 to root 2 by pi integral from 0 to infinity f of t cos omega t dt, and the kernel now is cos omega t. So here I am representing the kernel. Now the Laplace transform definition. The Laplace transform is defined by g of alpha is equal to integral from 0 to infinity f of t into e raised to minus alpha t dt. Here our kernel is e raised to minus alpha t. Now Now there are two other important transforms. They are Hankel transform and Mellin transform. So the Hankel transform, and the Hankel transform is also said to be Fourier-Bessel transform. Fourier-Bessel transform, and this is defined by g of alpha is equal to integral from 0 to infinity f of t, then Bessel function Jn alpha t dt. So the kernel here will be t into Jn alpha t. This is the kernel. Now last transform, Mellin transform. And here the definition is g of alpha is equal to integral 0 to infinity f of t into t raised to alpha minus 1 dt, and the kernel is t raised to alpha minus 1. Okay, so these are the definitions of various integral transform. Now here we have to study about Fourier transform, Fourier sine transform, Fourier cosine transform, and also about Laplace transform in this unit. Now if you consider the Fourier transform appear frequently in the studies of waves and in the extraction of information from waves, particularly when the phase is involved. So Fourier transform appear frequently in the studies of waves. Second, if you consider the output of a stellar interferometer, then the output of a stellar interferometer involves the Fourier transform of the brightness across the stellar disk. The Fourier transform of the brightness across stellar disk will give you the output of the stellar interferometer. And if you consider the Fourier transform of the amplitude of scattered X-ray in an atom, then that will be the electron distribution. So electron distribution in an atom can be obtained by taking the Fourier transform of the amplitude of the scattered X-ray. Many problems whose solutions are difficult in original coordinate system can be solved relatively easily in the transformed space. So let us consider an original problem, and its solution of the solution of this original problem is very difficult in the original space. So this way is very difficult. Then we can take the integral transform of the problem. Then we will get problem in the transformed space. So this is the integral transform of the problem. Integral transform. Now in the transformed space, if you solve the problem, then this way will be, it will be relatively easy to solve the problem. Relatively easy solution. So if you solve the problem, then you will end up in solution of the problem in the transformed space. And if you take the inverse transform of the solution, then you will be back to the solution of original problem. So this is the inverse transform. So what is the result? The result is many problems whose solutions are difficult in the original coordinate system can be solved relatively easily in the transformed space. Let us consider the Fourier transform of Gaussian. So e raised to minus a square t square represents a Gaussian function. Let us consider the Fourier transform of this Gaussian function. We have the definition g of omega is equal to 1 by root 2 pi integral from minus infinity to infinity f of t e raised to I omega t dt. Let us substitute for f of t. as e raised to minus a square t square. So this will be equal to 1 by root 2 pi integral from minus infinity to infinity e raised to minus a square t square e raised to I omega t dt. Okay, so the exponential e raised to, now here we have e raised to minus a square t square plus I omega t. Now this quantity, the exponential quantity, that is minus a square t square plus I omega t, this can be written as this is equal to minus a square into t minus I omega by 2a square whole square minus omega square by 4a square. If you expand this term, you will have t square plus I square omega square by 4a raised to 4 minus 2t I omega by 2a square. And നിങ്ങൾ ഈ a square കൂടെ ഉള്ളിലേക്ക് മൾട്ടിപ്ലൈ ചെയ്ത് ക്യാൻസൽ ചെയ്താൽ you will get back to this term. Okay, so this thing you can verify. So I can write down this equation as this is equivalent to 1 by root 2 pi integral from minus infinity to infinity e raised to minus a square into t minus I omega by 2a square whole square minus omega square by 4a square into dt. So this whole quantity exponential ആണ്, e raised to ആണ് this whole quantity. Okay, now this can be written as, എനിക്കിവിടെ നമ്മൾ integrate ചെയ്യുമ്പോൾ with respect to t ആണ് integrate ചെയ്യുന്നത്. So എനിക്കിവിടെ e raised to this term ഒരു constant ആയിട്ട് വരും. So that constant എനിക്ക് പുറത്തെടുക്കാം. So this will be equal to 1 by root 2 pi e raised to minus omega square by 4a square integral from minus infinity to infinity e raised to minus a square into t minus I omega by 2a square whole square dt. Now we have to integrate this expression. This expression can be integrated using gamma function. If we substitute t minus I omega by 2a square is equal to y, then this can be written as integral from minus infinity to infinity e raised to minus a square y square dy. And if you integrate this equation, this integral will be equal to root pi by a. So if you substitute it back here, then this will be equal to 1 by root 2 pi e raised to minus omega square by 4a square into root pi by a. So this whole integral is equal to root pi by a, and this is equivalent to 1 by a root 2 e raised to minus omega square by 4a square. So we took the Fourier transform of a Gaussian function and we ended up in another Gaussian function, a Gaussian function in omega space, 1 by a root 2 exponential minus omega square by 4a square. This is again a Gaussian function. And this Gaussian function is in omega space. So Fourier transform of a Gaussian is a Gaussian. Now let us evaluate the integral from minus infinity to infinity e raised to minus a square y square dy. So let us substitute a square y square is equal to t, then y square will be equal to t by a square, and if you differentiate this expression, then you will get a square into 2y dy is equal to dt, or dy is equal to dt by 2ya. So that will be equal to dt by, what is y? Y will be equal to root t by a. So if I substitute that, then this is 2 root t by a will go here in the numerator by a. So this will be equal to dt by 2 root t into a. So if I substitute it back here, then you will get integral from minus infinity to infinity e raised to a square y square is t. So e raised to minus t. And what is dy? Dy is equal to dt by 2 root t into a. Now the integral is from minus infinity to infinity. So I can make this integral limit from 0 to infinity. And if I take 0 to infinity, then there will be twice of this integral. So this can be written as 2 by, now this 2 and a I am taking outside, 2a, the integral limit from 0 to infinity e raised to minus t into t, this root t. So this will be t raised to minus half dt. Now we can compare this term with our definition of gamma function. We have gamma z is equal to integral from 0 to infinity e raised to minus t raised to z minus 1 dt. And if you compare these two, then you will get here z minus 1. This t raised to z minus 1 is equal to minus half. So minus half is equal to z minus 1. So that means z is equal to minus half plus 1. So that will be equal to 1 by 2. Or you will have gamma 1 by 2, and gamma 1 by 2 is equal to root pi. Okay. So if we cancel this 2 with this 2, then if you substitute this back here, then you will have root pi by a, root pi by a, and that we have already substituted. This integral is equal to root pi by a. Development of Fourier integral. We have in the interval minus L to L, the Fourier series is represented by f of x is equal to a0 by 2 summation n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L, where here an is equal to 1 by L integral from minus L to L f of t into cos n pi t by L dt, and bn is represented by 1 by L minus L to L f of t sin n pi t by L dt, and here n varies from 1, 2, 3, etc. And here the value n starts from 0, 0, 1, 2, etc. When n is equal to 0, you will have the value of a naught. Okay. And if I substitute an and bn here in the expression, then we will get the f of x is equal to 1 by 2L integral from minus L to L f of t dt plus next term 1 by L summation n is equal to 1 to infinity. Now you have for an, you will have this cos term and this cos term also, cos n pi x by L. So that will be equal to summation n is equal to 1 to infinity cos n pi x by L, then integral from minus L to L cos n pi t by L dt. Okay, plus next bn in the term. Next that will be 1 by L summation n is equal to 1 to infinity sin n pi x by L, then integral from minus L to L f of t sin n pi t by L dt. Now we have the equation cos A minus B is equivalent to cos A cos B plus sin A sin B. So if we expand cos n pi by L into t minus x, then this will be equal to cos n pi by L t into cos n pi by L x plus sin n pi by L t into sin n pi by L into x. Therefore, this f of x can be written as, therefore, f of x is actually equivalent to 1 by 2L minus L to L f of t dt plus 1 by L summation n is equal to 1 to infinity f of t into cos n pi by L into t minus x dt. Okay, so if you expand this term, then you will get these terms and you will get this expression. Okay, now let us take the parameter L goes to infinity. So let the parameter L is going to infinity, then the limit from minus L to L will change into minus infinity to infinity. Also we set n pi by L is equal to omega. Then pi by L is equal to delta omega. And with L goes to infinity. And we are setting these three conditions. Then our f of x will be f of x is equal to first term vanish cheedu, then the second term will be 1 instead of this 1 by L, you can write down 1 by pi summation n is equal to 1 to infinity delta omega. So 1 by L ഇവിടെ നമുക്ക് ഡെൽറ്റ ഒമേഗ ബൈ പൈ വരും 1 by L. സോ ഞാൻ ആ 1 by പൈ എടുത്തു, ബാക്കി ഡെൽറ്റ ഒമേഗ എഴുതി. Then integral from minus infinity to infinity f of t. So actually in this equation 1 by L summation, now here we have a integral from minus L to L. So minus infinity to infinity f of t. Now cos term, cos n pi by L is equal to omega. So cos omega then t minus x dt. Okay, so f of x നമുക്ക് ഇങ്ങനെ എഴുതാൻ പറ്റും, f of x is goes to 1 by pi, this term വരും, represented as f of x is equal to 1 by pi. I am replacing the summation as integral from 0 to infinity d omega, then from minus infinity to infinity f of t cos omega into t minus x dt. This is our resultant expression. This is the Fourier integral. So it is to be emphasized that this equation, that is Fourier integral, we developed as a purely formal, and it is not a rigorous derivation. Okay, so this is the Fourier integral. Fourier integral exponential form. We have the Fourier integral as f of x is equal to 1 by pi integral from 0 to infinity d omega minus infinity to infinity f of t
cos omega t minus x dt. Now here this cos function, cos omega t minus x, is an even function of omega. Cos omega t minus x is an even function of omega. And if you consider the sine function, sin omega t minus x is an odd function of omega. And the integral of an odd function over a symmetric interval will be 0. So we can write down this f of x as f of x is equivalent to 1 by 2 pi integral from minus infinity to infinity d omega integral from minus infinity to infinity f of t into cos omega t minus x dt. So ഇവിടുന്ന് ഇവിടേക്കുള്ള ചേഞ്ച് എന്താണ്? ജസ്റ്റ് ഇവിടെ നമ്മുടെ ഇന്റഗ്രൽ 0 to ഇൻഫിനിറ്റി ആണ്. ഞാൻ ഇവിടെ ഇന്റഗ്രൽ മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി സിമെട്രിക് ഇന്റർവെൽ ആക്കി മാറ്റി. സോ ഇൻസ്റ്റെഡ് ഓഫ് 1 by pi ഇവിടെ 1 by 2 pi ആക്കി. ഓക്കെ, നൗ സെയിം എക്സ്പ്രഷൻ നമ്മൾ സൈനിൽ എഴുതിയാലോ? സൈൻ ഒമേഗ ടി മൈനസ് എക്സ് ഒരു ഓഡ് ഫംഗ്ഷൻ ആണ്. ആൻഡ് ഇന്റഗ്രൽ ഓഫ് ആൻ ഓഡ് ഫംഗ്ഷൻ ഓവർ എ സിമെട്രിക് ഇന്റർവെൽ വിൽ ബി 0. സോ ഇഫ് നമ്മൾ ഇതേ എക്സ്പ്രഷൻ ഇവിടെ sin omega t minus x ആയിട്ട് എഴുതിയ that will be equal to 0. So next equation is f of x is equal to 1 by 2 pi integral from minus infinity to infinity d omega minus infinity to infinity f of t into sin omega t minus x dt, and that will be equal to 0. Now if I add these two equations, then we can write down the equation as, see, we have the equation e raised to I theta is equal to cos theta plus I sin theta. So if I multiply this equation with a factor I and add these two equations, then f of x will be equal to 1 by 2 pi integral from minus infinity to infinity e raised to minus I omega x d omega integral from minus infinity to infinity f of t e raised to I omega t dt. So t into f of t e raised to I omega dt term ഒന്നിച്ച് എഴുതി. Then I omega s d omega x next ഒരു integral ആയിട്ടും ചെയ്തു. Now this is the Fourier integral in the exponential form. The Dirac delta function derivation. Our Fourier integral in the exponential form can be written as, this is equivalent to 1 by 2 pi integral from minus infinity to infinity e raised to I omega t minus x d omega into f of t dt. Just നമ്മൾ ഇന്റഗ്രൽ ഒന്ന് rearrange ചെയ്തു. Then the quantity inside this bracket, this can be written as, this is equivalent to minus infinity to infinity f of t 1 by 2 pi minus infinity to infinity e raised to I omega t minus x d omega into dt. So just to rewrite ചെയ്തു. Now the quantity inside the curly bracket, this quantity will behave as a delta function. So this can be written as, this is equivalent to minus infinity to infinity f of t into delta t minus x dt, where delta t minus x is the quantity in the bracket. Delta t minus x is equal to 1 by 2 pi integral from minus infinity to infinity e raised to I omega into t minus x d omega. And this is a very useful representation of delta function. Fourier transform inversion theorem. We define Fourier transform of a function f of t as the Fourier transform of function f of t is defined by g of omega is equal to 1 by root 2 pi integral from minus infinity to infinity f of t e raised to I omega t dt. Then the inverse transform of this function will be f of t is equivalent to 1 by root 2 pi minus infinity to infinity g of omega into e raised to minus I omega t dt. Now the same definitions can be rewritten in 3 dimension as in 3D space this will be equal to g of k is equivalent to 1 by 2 pi raised to 3 by 2 integral from minus infinity to infinity f of r into e raised to I k dot r d cube r, and the inverse transform f of r will be equivalent to 1 by 2 pi raised to 3 by 2 minus infinity to infinity g of k e raised to minus I k dot r into d cube k. Fourier cosine transform. We have the Fourier transform of a function as g of omega is equal to 1 by root 2 pi integral from minus infinity to infinity f of t into e raised to I omega t dt. And we know that e raised to I theta is equal to cos theta plus I sin theta. So this can be written as 1 by root 2 pi integral from minus infinity to infinity f of t into cos omega t plus I sin omega t into dt. Now suppose f of t is a even function, and if f of t is even function, then f of x will be equal to f of minus x. F of x will be equal to f of minus x. If you consider cos omega t, then cos omega t is a even function. Cos omega t is even function, whereas sin omega t is a odd function. An integral of an odd function over a symmetric interval will be 0. So this g of omega can be written as 1 by root 2 pi integral from minus infinity to infinity some f of t into cos omega t plus I by root 2 pi, then integral from minus infinity to infinity f of t into sin omega t dt. And we know that if the function is if you consider sin omega t, then sin omega t is a odd function, and so this term will vanish here because integral of an odd function over a symmetric interval is 0. So if f of t is even function, so let me represent this by some fc. Fc of x is equal to fc of minus x. Then this f of t can be written as fc of x. So f of t നമ്മുടെ ഫംഗ്ഷൻ ഈവൺ ഫംഗ്ഷൻ ആണെങ്കിൽ ഞാൻ അതിനെ എഫ് സി എന്ന് റെപ്രസെന്റ് ചെയ്തു. സോ ഇവിടെ എനിക്ക് ഈവൺ ആയിരിക്കും. ദിസ് നൗ കോസ് ഈസ് ആൻ ഈവൺ ഫംഗ്ഷൻ. സോ ഈവൺ ഇൻറ്റു ഈവൺ ഫംഗ്ഷൻ വരും. ബട്ട് ഇവിടെയോ, ഇവിടെ ദിസ് ഈസ് ഈവൺ ഫംഗ്ഷൻ, സൈൻ ഒമേഗ ടി ഓഡ് ഫംഗ്ഷൻ ആണ്. ഓഡ് ഇൻറ്റു ഈവൺ വിൽ ബി ഓഡ് ഫംഗ്ഷൻ. എന്നാൽ ഒരു ഓഡ് ഫംഗ്ഷൻ നിങ്ങൾ സിമെട്രിക് ഇന്റർവെല്ലിൽ ഇന്റഗ്രേറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ 0 ആയിരിക്കും. സോ ദിസ് ടേം 0 ആവും. സോ യു ഗെറ്റ് ദി Fourier transform of the function as j c of omega is equal to root 2 by pi integral from 0 to infinity fct into cos omega t dt. Now the inverse transform fc of omega will be equal to root 2 by pi integral from 0 to infinity j c omega cos omega x into d omega. Okay, so this will be the cosine transform and inverse cosine transform. Similarly, we can represent the Fourier sine transform and inverse sine transform. So consider f s of x is equal to the fs of x is equal to minus fs of minus x, an odd function. Odd function ആണെങ്കിൽ fs of x will be equal to minus fs of minus x. Then g of omega will be equal to 1 by root 2 pi integral from minus infinity to infinity fs of t into sine omega t. Okay, so the Fourier sine transform and inverse sine transform will be j s of omega will be equal to root 2 by pi integral from 0 to infinity fs t into sine omega t dt, and fs of x inverse transform will be equal to root 2 by pi 0 to infinity gs of omega into sine omega x d omega. ഈ Fourier ട്രാൻസ്ഫോമിന്റെയും ഇൻവേഴ്സ് Fourier ട്രാൻസ്ഫോമിന്റെ ഡെഫിനിഷൻ നിങ്ങൾക്ക് വേണമെങ്കിൽ നേരെ റിവേഴ്സിലും ഡിഫൈൻ ചെയ്യാം. ഇതിനെ ഞാൻ Fourier ട്രാൻസ്ഫോം ആയി ഡിഫൈൻ ചെയ്താൽ ദിസ് ഇക്വേഷൻ Fourier ട്രാൻസ്ഫോം ആയി ഡിഫൈൻ ചെയ്ത് കഴിഞ്ഞാൽ ദിസ് ഇക്വേഷൻ വിൽ ബി ഇൻവേഴ്സ് ട്രാൻസ്ഫോം. നൗ ഈ ഇക്വേഷൻ ആണ് ഞാൻ Fourier ട്രാൻസ്ഫോം ആയി ഡിഫൈൻ ചെയ്യുന്നതെങ്കിൽ this equation will give you the inverse Fourier transform. Okay, so that's about sine transform. So these two equations represent the Fourier sine transform.